Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we have learned about the subject on W3601 protection and switchgear for 2021 regulations. In this presentation, we have discussed the topic on numerical protection in power systems. So, content list the topics cover definition, numerical distance protection, numerical differential protection. Numerical protection. So, numerical protection is a modern protection technique in power systems that uses microprocessors or digital computers to detect faults and operate relays. And it replaces electromechanical, and static relays. Numerical distance protection. It protects transmission lines using distance, that means impedance measurements of the line impedance of the relay's installation point. Then fault location is determined based on the impedance. That means when a protection system employs numerical distance relays to monitor and protect power lines, it is referred to as a numerical distance protection scheme. Working of numerical distance protection. In shortly, uses CT and VT to get current and voltage signals. The signals are sampled, digitized and processed. This process involves separating the fundamental frequency signals from complex post-fault waveforms, which often include transient DC offsets and various harmonic frequencies. Numerical distance protection and signal processing. Filters remove harmonics and noises, and extras fundamental frequencies for accurate analysis. And then operation of numerical distance protection. A relay calculates resistance and reactance. If fault is within zone, send trip signals to the circuit breaker. This is the diagram of numerical distance protection. Relays calculates resistance and reactance values to determine if a fault occurs when it is designated protective zone. Then have to learn numerical differential protection. So numerical differential protection compass incoming and outgoing currents used to protect transformers, generators, and motors. Then basic concept of differential protections. It works on difference in current. If difference exceeds the limit, the fault detected. So this simple differential approach is also referred to as the circulating current differential protection, commonly known as the Nurse-Price protection scheme. Then behavior of simple differential protection under normal conditions. So currents entering and leaving are equal. So no current flows through the relay. There is no trip to the circuit breaker. That means the current transformer selected with ratios ensuring the secondary currents match during normal operation. For protected components such as 1:1 ratio transformer, generator winding or busbar, the primary currents on both sides remain balanced during normal conditions. Consequently, the protective CTs are designed to have identical ratios to maintain this balance. Denoting the CT ratio as N, secondary transformer from CT1, secondary transformer from CT2, and load current. This is a diagram of under normal condition of numerical differential protection. So operation normal condition, current circulate in CT secondary circuit and relay remains inactive. That is if there is no fault means. Internal fault conditions, current difference increases, relay detects faults and sends trip signals. In external fault condition, current remains balanced, the relay does not operate, it ensures stability. Numerical differential protection, it introduced digital uh, it introduced digital implementation digital implementation of differential protections. So the block diagram of this numerical differential protection steps involved CT inputs, signal conditioning, ADC conversion, and microprocessing. So relay algorithm calculates differential current ID, registering current IR. Decision: if ID greater than setting means trip, else no trip. Bias and slope characteristics. So it prevents false tripping. That means handles CTRS and external faults. Harmonic then harmonic restraint. It detects transformer inrush current. It prevents unnecessary tripping. Next one, trip decision and output. It combines all conditions, sends trip signal to the circuit breakers. Advantages: high accuracy, fast operation, selective protection, low maintenance, and support SCADA. Disadvantages: high initial cost, complex design, needs skilled handling, sensitive to CTRS. Applications used in transformers, generators, bus bars, motors. Conclusion of this presentation: numerical protection is fast, reliable, and accurate. So it is used advanced digital algorithms to ensure fast and accurate operation. Due to its speed, selectivity, and stability, it is widely used in modern power systems. List the textbook and authors for your further study. Thank you.